We will observe how the energy ladder varies with temperature, and the energy ladder has a constant energy level spacing of 5 times 10 to the negative 21 joules. So the equation we'll use here, shown in red. So what I'm going to do is solve the first problem where it says calculate the partition function of an energy ladder at 100 Kelvin. So to calculate the partition function, that would be take 1 minus e to the negative energy level, which is 5 times 10 to the negative 21 joules. And then you multiply Kb, which is Boltzmann constant, and temperature, and you get 7.25 times 10 to the 20 inverse joules. And then you'd get the partition function to be 1.03. So the next question asks to calculate the molar heat capacity of energy ladder at 100 Kelvin. So to do that, you use this equation to calculate the heat capacity. Avogadro's number times Boltzmann constant, energy level, kBT squared. E and beta is already defined. Oops, that should be beta times the energy level. So, and then over E beta energy level minus 1, and the bottom is squared. So to do this, you basically plug in the values here, and you'd get CV equals 109.14 times 0.0281, and you'd get around 3.08 joules per mole Kelvin. So that's the molar heat capacity at 100 Kelvin. So to calculate the partition function Q of an energy ladder at 5000 Kelvin, to do that, you do the same thing. You take Q, 1 minus e to the negative energy over kBT, and that would give you, plug in Boltzmann constant and the temperature, you'd get 14.3. And CV, you use the same equation above, and you should get around 8.28 joules per mole Kelvin. So this is an interesting number here. It's close to R, which is 0.314. So the heat capacity at low temperature, let's see what that would be. What is the partition function at 5 Kelvin? So to do that, you use the same equation above here, and you get Q equals 1. And to figure out the heat capacity at 5 Kelvin, that would also plug in the same equation, and you get heat capacity of 0 joules per mole Kelvin. So summary is the energy ladder. So here's summary. The energy ladder capacity to absorb heat increases to a limiting value at high temp. And that limiting value is R, which is 8.314. And that's it.